welcome back, everyone. I just wanted to introduce Ros Coggon, who's a Royal Society University Research Fellow at the University of Southampton. Just a bit of background on Ros, because I think she's an excellent example of an early career researcher taking the lead in scientific ocean drilling. But Ros sailed on, I think, 3 ODP and IODP cruises during her PhD, one of which pretty much is the sole petrologist on board the cruise. So instantly, as a PhD student, had major responsibilities for a number of key sections in the scientific results. She was very heavily involved in the renewal of UK membership of scientific ocean drilling that just went through a couple of years ago, which is always a rather challenging battle. And also recently is lead proponent of the South Atlantic Transect proposal that is being implemented as IODP expeditions 390 and 393. And actually, throughout the pandemic, Joyde's Resolution has been operating in the South Atlantic, putting in a lot of infrastructure to re-entry cones and casing to enable us to do more science on those expeditions that will run next year. And also, why she's talking today is that she was co-editor of this large new community document that was put together over the last year or so on behalf of the community. So welcome, Ros, and over to you.
Thanks, Damon. So Damon's already shown you the front cover of the new science framework for ocean drilling that was published online at the end of last year, following a very intensive virtual year of meetings to put it together and write and develop. And this is the document that is going to guide multidisciplinary seafloor research into the interconnected processes that characterize the complex Earth system and shape our planet's future. And I think perhaps following on from what Damon said already this morning, one of the key words in that mission statement is guide. So this document guides what we will do over the next 3 decades of scientific ocean drilling, but it does not dictate what we will do over the next 3 decades. So there is plenty of scope for all the scientists involved to come up with good scientific ideas that they want to investigate with ocean drilling and justify that idea through their proposal that they submit. This is a community document. Again, Damon has already said that one of the most important things about the international collaboration in scientific ocean drilling is that it is bottom up. And this document was produced with Anthony Coppers and I as co-lead editors and a team of nearly 50 writers and reviewers, but also vast community input from the entire scientific ocean drilling community, which actually started with a series of 6 workshops in 2018 and 2019 with 650 members of the community represented at these different international meetings. So this is a document for the community by the community. And actually representatives from each of those workshops came together to form a science framework working group and look for the synergies between the outputs of those different workshops that discussed what they thought their priorities were for the next phase of ocean drilling. And there were synergies, there were lots of overlaps between the outputs of these different meetings, which of course was nice. And the things that the community wanted us to focus on moving forwards were being an interconnected program, focusing on the interconnections in our science, that we be aspirational, but that we focus on things that have a true societal impact, that we should remain inclusive, and that speaks to the international collaboration that we've been working using that mode of operation for the last 2 decades, or well, 3 or 4 decades, and that we should continue that, and that we should focus on continuing to develop our technology as well. And that as a result, we would need a new structure for the science framework, that it should be audience specific and that it should be digital and hyperlinked. So not only do we need to rethink how we put our science together, but also how we presented it. And so we came up with a new structure for the framework, which revolved around investigating Earth as an interconnected system. And this structure combines broad interconnected science topics and aspirational goals. And it includes strategic objectives, which are broad areas of scientific inquiry that focus on understanding the interconnected Earth system. Flagship initiatives, which are long-term drilling endeavours that aim to inform issues of particular interest to society and typically combine goals from multiple strategic objectives. And then we also have some enabling elements, which are key facets of scientific ocean drilling that will facilitate our research activities and enhance our scientific output and also maximise their impact. So we're integrating the way we do our outreach into our actual science framework. And then over on the right, you will see a list of enduring principles. There are 8 enduring principles, and these are really key principles of scientific ocean drilling that already exist, that have always been important to us, and we have explicitly stated these because we want them to remain important to us moving forwards. And I just want to focus on how this framework differs from predecessor science plans, because I'm sure many of you are familiar with the science plan that Damon already showed us, the 2013 through 2023 science plan. Many of you probably were involved in writing it. And the difference this time around is that what we have is a science framework, not a science plan. So this framework has been put in place, as Damon already said, before the programme that will programmes that will implement it have been developed. You'll notice if you think back to the front cover that I showed, there was no programme acronym on the front cover. It just said Exploring Earth by Scientific Ocean Drilling. So we don't have a programme yet for beyond 2023. That work still needs to be done. We don't know what the programme will be called yet. You will notice that on the front cover, we did have the word drilling. So drilling is back. And we also had science on our front cover, possibly for the first time. We've been the deep sea drilling programme, we've been the ocean drilling programme, we've been the international, there's the integrated ocean drilling programme and the integrated ocean discovery, international ocean discovery programme. We have never had science and drilling in our title at the same time. So this framework forms the foundation on which those programmes will be built, and those 8 enduring principles will be really important to building that programme. And again, this has been written by the community for the community. Because it is a framework, not a plan, if you look through the document, you will not see specific platforms or ships mentioned. That's partly because we don't know exactly what platforms will be available, but also because this is a long range plan through 2050. And whatever platforms are available when we start will not necessarily be the platforms that are available when we finish. So the platforms will develop and change with time. And in fact, from an MSP point of view, which of course is the focus of the next few days, that really shouldn't matter, because the whole point of MSPs is that we should not be limited by the platforms that we currently operate. If you have a problem that requires a vessel, a platform that will drill in the oceans to solve it, then that platform will be sought and will become an MSP and become part of our tool set to develop, to investigate these questions. So as I said, it was published online at the end of last year, and I just got a few snapshots of the document quickly to show you. So go back to the cover and we go through some pages. So one of the key things that came out of those international meetings was that we shouldn't think of our science in siloed themes anymore. The front cover of the previous science or current science plan that Damon showed had 4 themes written across the front of it. And they are, just as a reminder, climate, deep life, planetary dynamics, and geohazards. And everyone felt that we should start to think of our science in a more interconnected way and address the connections between these themes. And so we came up with this representation of what we consider to be the whole Earth system. And you'll see that actually many of the themes of the current science plan have become the jigsaw puzzle pieces in the middle that form the basis of the Earth system, surrounded by these 3 arrows that connect it. These are processes or parameters or properties of the Earth system that connect these different parts of the system. And the key thing here moving forwards is that we have 7 strategic objectives that are supposed to collectively encompass that interconnected system. So they look for the connections between different parts of the system. And they are habitability and life on Earth, the oceanic life cycle of tectonic plates, Earth's climate system, feedbacks in the Earth system, tipping points in the Earth system, global cycles of energy and matter, and natural hazards impacting society. And so in each one of these, we hope that we would explore connections between different things. So for example, is there a relationship between microbial alteration of the ocean crust, the rheology of the ocean crust, and hazards being generated in a subduction zone? So we're not putting life into one box and hazards into another. We're looking for the ways that the different parts of our research connect. The way that these have been written, they're deliberately broad and open, but focus on the interconnections. So here I just have a snapshot of one of the pages of one of the strategic objective chapters. And what I want you to notice here, obviously I don't expect you to read it, what I want you to notice here is that nowhere in this page is there a numbered question. So the current science plan across those 4 themes has 14 numbered challenges, which were questions that we could address with scientific ocean drilling. We have done away with questions, specific questions, and instead we have described various topics that we think are important that can be addressed by scientific ocean drilling that fall into these 7 strategic objectives. They're broad and open, and we have these interconnections. So there are these grey bits of text in grey, which are actually in the online version are hyperlinked to other strategic objectives and are designed to emphasize the links between the different strategic objectives. So with them being broad and not being confined to specific questions, the idea is that you can express your scientific problem. You should be able to find somewhere that it relates to the framework. And if we have failed to capture your science, then that is a reason for the science framework to evolve with time, and we'll come to that in a minute. We also have 5 flagship initiatives, and these are long-term drilling endeavours that will require multiple expeditions. So we were able to include these because a key difference between this science framework and previous science plans is that we have 3 decades of science that we are aiming to fill here, whereas previous science plans have been decadal. And that has had several limitations. And one is that some of our proposals, if you've written a proposal before, you'll know that it can take several years for a proposal to get through the review system. That is why Damon's asking us to focus on what the future science framework encompasses rather than the current science plan, because any proposals that are being developed now at this stage won't be being implemented for several years. So it can take several years to get from idea through site survey, through scheduling, and actually get your science, get your samples to do your science. So having a 10-year plan when you might actually have years for a project isn't ideal. But also, even on top of that, some of the projects themselves will require multiple phases of drilling and take multiple years to implement. And so by giving ourselves longer, we're able to include these ambitious long-term projects that require multiple expeditions. And some of these flagship initiatives will require multiple expeditions because they might require a concerted drilling effort in one place. For example, if you want to drill a really deep hole, that's going to take multiple expeditions. They might require multiple expeditions because they require a network of geographically distributed holes across the planet that need to be drilled in specific locations to form grids or networks. And again, that requires time. They might require multiple expeditions because they need to build up a database of results. For example, to explore life and its origins, we might need a genomic database across multiple holes that are being drilled for other expeditions across the planet, building up over time. And because these flagship initiatives do require multiple expeditions and coordinated thinking, they're laid out slightly differently in the framework, and they do all include a way forward section, which is a very high level suggestion of the sorts of things that might need to be done over the next 3 decades in order to accomplish that objective, to achieve that mission. But again, they're not specific, and they're not dictating exactly what should be done. No specific geographic locations mentioned, no methods. So it's left very much up to the scientists to come up with a way of implementing these flagship initiatives, and they will most likely happen through workshops similar to how we're doing this process now. The framework also has enabling elements, and these are things that we want to include and that we think are important to our drilling projects, all of our expeditions. And these include considering our broader impacts and how we do our outreach and how we communicate our results to a series of different audiences. That we explicitly saying that land to sea drilling is important. And so this is working with continental drilling programs, including ICDP, in a coordinated way to drill both on land and in the oceans. And ICDP will have a similar chapter in their new science, plan as well. And MSPs could form an important part of that strategy of drilling land to sea transects. We're also trying to forge new and stronger links with the extraterrestrial science community. And we're explicitly saying that technological development and big data analytics are going to be important, increasingly important moving forwards. And this relates again back to Damon's point that we're beyond the exploration phase and we're now able to do in a real-time monitoring and in situ experimentation. In fact, the reason that I chose this flagship initiative was that one reason that a flagship initiative might take multiple decades to complete is that we might need to install a series of seafloor instrumentation. So in order to do this, we need to drill the holes in the first place, and then we'll need other expeditions to install devices on the seafloor. So if we come back to how the science framework is different from its predecessor science plans again, and think about the actual science content of it, then it's going to require us to investigate the whole Earth system, not just think in individual siloed themes. And so there's going to be an increasing focus on multidisciplinary science. And again, Damon mentioned this, you can have a drilling expedition that focuses on one thing, and if that's a well justified science question and it stands alone and there isn't anything else you can do in that site, that's fine. If it's well justified, then that can still happen. But if we're going to investigate Earth as an interconnected system, then our science needs to be interconnected. And so increasingly, there's going to be a need to do multidisciplinary science. There is going to be an increasing emphasis on science which has either societal impact or societal interest. And so when you're thinking about your idea for your MSP expedition, think about how it's going to impact society, why society might care or be interested in what it is that you are going to propose to address. The strategic objectives are, as I said, purposely broad and open, so that you shouldn't feel limited by what we've written down. We weren't trying to be all-encompassing. We were trying to illustrate the strategic objectives with examples of things that would fall into that category, but they are not all-encompassing, and so you can find ways to fit your science into those strategic objectives. We have the flagship initiatives that will require coordinated multiple expedition strategies, and so MSPs could form part of that. You might have part of a flagship initiative that requires all sorts of different vessels. So you might need riserless drilling, but you also might need to do a component of shallow water drilling or something that requires an MSP. And certainly this different science structure of the framework is going to require us to implement our science in a different way. And that is ongoing work. The JRFB has set up a working group already to think about how it's going to affect both not just the implementation in terms of setting up the new program, but also how it's going to affect the proposal and submission and review process. But for now, we'll carry on with the current structure. I said at the beginning that the science plan was written by the science community for the science community. And one of the key messages that came out of those planning workshops that we had was that we needed to be audience specific. And so in addition to the 100-page plus document that is to guide scientists in their preparation of proposals, we have written two shorter versions, a 2-page pamphlet that is intended for use for just explaining what we do to the public, and a slightly longer 12-page pamphlet. And so I appreciate that you probably have not got time to read the framework if you haven't read the framework before you start writing your preliminary proposals later on today, but you have probably got time to take a quick glimpse at the 12-page pamphlet that goes through some of the stuff that I've just said and outlines the structure of the framework. And that is on the same website at iodp.org. Back to other ways that this framework is different. Again, this is a plan for the mid-21st century. It's much longer ranging, as I said, will likely span across multiple program cycles. And that means that we need to maintain, revise, and evaluate it. And the reason that I included this comes back to the point that Damon made, that the framework, like all science plans we've written, is a snapshot in time, but we recognize that up front this time. So whilst we've written a framework that takes us through 2050, it is also explicitly stated in the opening sections of the framework that this will be reviewed and revised every 5 years and evaluated. And that will allow us to both include new areas of science that have come up through either our own or other communities' discoveries. It will also allow us to add new strategic objectives and or flagship initiatives as and when the community comes up with new ideas. So this is just a snapshot in time, and it will evolve as we move forwards. And that's everything that I've got. So if anyone has any questions, I'd be happy to take them.